What is real? How do you define real?
You can't jump into cash. Cash is trash. What do? You get out.
Kiara Bickers is a writer, autodidactic systems thinker. She writes using mental models to better understand systems, values, and life. She is the author of Bitcoin Clairity, the complete beginner's guide to understanding what is Bitcoin and why is it important, using everyday examples and familiar language. Bitcoin Clairity separates technical concepts from industry jargon and tells the story about how Bitcoin began and how each part of the system evolved into what it is today. Along the way, you'll discover how cryptocurrency directly combines politics with personal net worth and why that has people fighting for some perceived notion of control over Bitcoin. And it's the only Bitcoin book read by Kanye West. Kiara Bickers, welcome to the Bitcoin Matrix podcast. How are you?
Hey, I'm doing good. Thanks for the intro.
Yeah, and also I forgot to include in the intro that you're the systems admin at Blackstream, as well as a podcaster and YouTuber yourself.
Yeah, I dabble.
Yeah, you create quite a lot of content. So what is Blockstream? What do you guys do over at Blockstream? I hear you guys are putting satellites up into the sky. You got data feeds. You're doing side chains.
So Blockstream is a really interesting company to me because it's described as a vertically integrated company, meaning like really what happened is it hired a lot of people who were interested in Bitcoin very early on in Bitcoin itself. So like, I believe 2012, 2013 era. So it was hiring a lot of the people who were contributing to to working on Bitcoin at a time when people weren't getting paid for that and the value of Bitcoin itself was relatively low. So it collected just like extremely good talent and we sort of just built things that were interesting. So the company bought Green. It was once branded as Green Address, but now it's just called Green. But that's a wallet. And then you mentioned Blockstream Satellite. So that was based off the idea that it turns out that like the way sending and receiving happens in Bitcoin is not very tightly specified, meaning that you could send transactions in a number of different ways, one of them being satellite, and it adds to the resiliency of the network. So we just did that as a project. My boss is actually the lead on that one. And then we also do mining that was announced not too long ago. What else? There's a core product, which is, as you mentioned, a side chain, but people don't really understand that terminology. But basically what it is it's a clone of the Bitcoin blockchain that allows you to do more stuff than Bitcoin itself, but using a multi-sig, which might be somewhat advanced, but it's just a transaction on Bitcoin. Using a multi-sig, we can move Bitcoin into this secondary blockchain. And then on this blockchain, you can have a greater dimensionality. You can have more greater range of motion to the things that you can do. For instance, you can have more private transactions. You could transact faster than you could on the Bitcoin blockchain. So that's a product. That product is called Liquid. Let's see. We also do a data feed. We also have a block explorer. So it's just a whole bunch of nerds that like to build things for Bitcoin.
Yeah. What are some of the things that are happening on Liquid?
Yeah, that's a good question. Right now, mostly it's tokenization, I would say. That would be the primary use case at the moment. Yeah.
Sure. And what's it like working with Dr. Adam Back?
Yeah, Adam Back is a character. I'd say that. Actually, so Adam Back isn't a contributing dev to Bitcoin, really. Not in like not like a grind kind of level. Like, let's see, Blue Matt is a contributor. Greg Maxwell is a major contributor, and those are all people who work at Blockstream too. So I would say the coolest thing, like working with Adam Back, is a lot like working with a lot of the other nerds that work on Bitcoin. Is it's a lot of talking about systems, talking about cool ways to do things. Like one of the funny conversations, I tried to like drop these in the book because it was just like so cool. But we were talking about building HSMs, like secure hardware devices. And the concept came up was like, okay, what if we could enclose, like for people who are actually in the space, I'll say this. Most people know that if someone actually gets in contact with your hardware device, like whether that be your Treasure or your Ledger, where you're storing your Bitcoins, it's pretty much compromised at that point. So there's things that you can do. And one of the things that they were talking about doing, all these cypherpunks I work with, they were talking about enclosing it in this sort of like epoxy, like a clear epoxy coating. And then you paint it black over that. So if anyone ever breaks the device, meaning they're trying to open it to access the actual module inside, it would just self-destruct. Right. And so it's like these crazy things that cypherpunks come up with to build more secure hardware is fun. That's what it's like working at Blackstream.
Yeah.
I worked for a guy he was my direct report for a while. His name is Wilkins, and he's like one of the best security guys in Silicon Valley, to my knowledge. And for the first like week that I was working at Blockstream, he just had me like picking locks.
like hardware locks?
I got pretty good. What's that?
Like real hardware locks? Like a master lock?
I built up to doing the dead lift, and that was like really as far as I could take it. But it's fun.
And what did you learn from that experience or that project?
Adversarial thinking. So if you were to try, adversarial thinking is not taught really anywhere. If you get a CS degree, they're not going to teach you adversarial thinking. If you do like network security, they might to some degree teach you like blue teaming, red teaming. But instead, Wilkins's approach was to give me a book based on, it's been a while since I read it, but it was basically about people who were breaking into buildings to like rob, like they were like diamond thieves or money, they're like bank robbers. And they would just describe like, oh, wow, look at this really secure door in San Francisco. I'm going to punch a hole through the drywall right next to it. And like, then they'd cut into the building and, steal whatever it was they wanted. Eventually they wrote a book about it, but that was the approach that I took to running servers. So, among other things, but yeah, just thinking about what your different threats are and how to defend against that has been one of the mental models that I took away from that.
Right. I don't know if you're getting a little feedback. I get a little feedback when you're talking.
I could try this. I have AirPods in.
I was going to change my headphones if that was the issue. I get a
can't
slight
hear
feedback.
myself because I'm not wearing headphones, but let's see. How's that?
I think that's better. Yeah. So I'll just jump right back into it if you think that's good.
Cool.
Yeah. So what is it like at Blockstream on a day-to-day basis? Is it a lot of these heady intellectual conversations about systems? And
I wouldn't say they're like heavily intellectual. They're extremely casual, but it's changed a lot since COVID, since we were always a distributed company, but for a long time, people would meet in cities like San Francisco and stuff like that. I had a lot of coworkers there. I lived there, but I've since moved and there's not a lot of like getting together. So it sort of changed a lot, but I would say the overall culture is still very similar. It's on one level, it's like really smart people talking about like cryptographic protocols, different security things. But on another level, it's also just like casual conversations over lunch about ways that they can improve existing infrastructure.
Interesting. Yeah. And where do you think Blockstream will be in 10 years or 20 years?
That's a great question. I mean, I think that the company has always positioned itself long-term. So, it depends on where Bitcoin is, right? So a lot of the excitement around the company is we bring in a lot of new people and a lot of new excitement around the company when the price of Bitcoin spikes, right? You have this whole hopium thing and this hype panic cycle. And when there's a lot of hype, obviously it gets a lot more excitement around existing companies. I don't think there is a company like Blockstream that's doing what Blockstream is doing, meaning Blockstream is so well tapped into the Bitcoin ecosystem, but just because it's touched every layer of Bitcoin.
Right. Yeah.
So, like IBM can't say that, Intel can't say that. A lot of the other like companies that have started side chains or even just like altcoins, they can't say that because once they fork off Bitcoin, they don't contribute back to Bitcoin anymore.
Right. Right.
And the company's just totally focused on like Bitcoin infrastructure. And to the extent that it benefits from that, I think it'll be doing pretty well in 10 years. I've been working there for almost 5. So it's been quite a journey in that short ride alone.
Right, right. So you've been there 5 years, and I think you've been interested in Bitcoin, at least coding and stuff, for 7, 8, 9 years now, maybe. So
yeah.
So how did you come to Blockstream? How did you come to Bitcoin? I guess kind of what's your rabbit hole story?
Sure. Oh, it definitely was a rabbit hole. So, I was interested in Bitcoin for mostly, I would say, like political slash ethical slash emotional reasons. So I heard of Ron Paul in 2012, and I was, gosh, I don't even know how old I was then, but I was in my probably like teenager, early 20s. So yeah, I was not necessarily hearing about Bitcoin, but I was hearing about the Fed. And then I started studying Austro-economics. Now, by studying, I just mean I was listening to podcasts. But to me, I was accumulating knowledge about Austrian economics in different ways that money could be done. I remember specifically Hayek doing an essay about the potential for private money. And then around the same time that I read that, obviously it was written much earlier, but around the same time that I read that, I probably heard about Bitcoin a number of times, but it really clicked that with that. And I was like, well, this isn't what Hayek envisioned, because he envisioned it to be like a company that was run by like a board, but this is probably better. So God, the price at that time was so low. Nothing in the industry was very serious, I would say. I was also not in the developer community at that time because I didn't know how to code. So for anyone who wanted to learn more about Bitcoin, let's say they were coming from a libertarian background in 2012, if you ask someone, how do I learn more about Bitcoin? They would always tell you to learn how to code. So that's what I did. And I learned how to code, and I couldn't say I was an exceptionally good developer. I mean, I spent 2 years learning C++, but I could do some things, but I wasn't by no stretch of the imagination a wizard. And I took a look at the Bitcoin source code after I thought I had learned some things. And I was like, wow, I am incredibly incompetent. I do not know how to read this. Like, what I learned about C++ did not translate into any understanding of Bitcoin Core whatsoever. And that was very frustrating. And all these articles about Bitcoin were all about UTXOs and just I would say overly complicated things. Like, they would take private keys all the way down to like zeros and ones, and it was just like, what, it didn't make any sense. So I was still interested in Bitcoin. I was sort of captivated by it, probably because I couldn't quite understand it. I understood the economic side of it, like the scarcity, but I didn't understand how code translated to cryptography. I didn't understand how you could create scarcity with cryptography. And even when I tried to understand the cryptography side of it, I wasn't making that, I wasn't satisfying my own questions. I don't know if I really did for many years, but I learned how to code. I studied Bitcoin to some extent, as much as I could. I did like what I would call like second layer programming to it. So like, I built the first Bitcoin paper wallet app. I was working with APIs that interface with Bitcoin. I would run a full node, but that still didn't translate into understanding how the whole system worked. And it wasn't until I started working at Blackstream. I had a couple of jobs in between there, but how I got my job at Blackstream, since you asked, I was basically just ranting about Bitcoin to anyone who would listen. I would go to these events. I would talk about Bitcoin some more. I went to this huge like Bitcoin. It was almost like a course, but it wasn't really. It was more just like a get together. It was called like Blockstream or a block. I don't even remember what it was called. It was a large get together where we met twice every day for however many weekends. It was like 5 weekends in a row, and it was like both days on the weekend. So it was kind of intensive. And we would just talk about like all this different stuff in cryptography. I remember talking to a guy there, and I was saying I had just heard of PGP, which to this guy who had been working in cryptography for so long, he's like, wait a minute, you heard about Bitcoin before you heard about PGP? Like, I don't think he's ever forgotten that interaction because it was so like shocking to him. It's kind of like if you meet someone who like has heard about Ethereum before they heard about Bitcoin, like, it's weird, right?
Yeah. But so, you're searching, you have all these questions, you're looking for answers. Austrian economics seems to be something that was a thread you were really pulling on.
Oh yeah.
Then it became coding, whether it was trying to understand the money behind or the scarcity behind or the technical aspects of Bitcoin. But now you're doing this deep dive in coding. What did you think? And I'm not saying you were looking for an answer right away, but I don't know if it was years before that or during this. What did you think you were going to do with these answers, like long-term career? Did you think you were going to become like an economics professor or a programmer, or was it just scratching an itch?
I don't know. So like, one of the weird things too is that like it would have been impossible to do what I did if I had planned it. You know what I mean? So like, I don't think certainly you can plan your career. If you decide to become a doctor, if you decide to become a cryptographer, you can certainly plan that. But some things, especially sysadmin in the tech industry, is just like classic for not having planned that career. It's just sort of like a tech job that people end up in. Yeah, so I didn't plan any of that. I just was really, really curious. I was curious about Bitcoin, so I learned economics. I was curious about Bitcoin, so I learned how to code. I was curious about Bitcoin, so I got a job working in Bitcoin, and then another job, and then another job, and then eventually I just got like the coolest job as an intern at Blockstream. And then, I had opportunities to maybe get a job as like a iOS developer or something like that, like at a wallet company. But, building wallets once you had worked with like cypherpunks wasn't quite as interesting.
Right.
That's only like one piece of the puzzle. And it's just been more fun. Like I've had the opportunity to learn about mining and stuff like that. Just really cool, really, really fun stuff. And yeah, so I ended up working at Blockstream because I was scratching an itch, and I'm still scratching that itch, I would say.
Yeah. Before we turn to the book, which I think is fantastic, well, I mean, what are some of the other things that you're interested in right now? I think I heard you on another podcast talking about like you were reading historical texts that were older than the Bible and looking at tablets and
Yeah.
transcribing them. It seems like you really, like to think through the way humans, I don't know if it's interact or just the systems that we rely on or how we operate, almost like looking at the whole thing as an operating system.
I mean, that's totally correct. And I think I've just really leaned into that in the past couple of years of my life, because I hadn't been able to pinpoint what it is that drives my analytical brain, because there's certain things that turn on and certain things that turn it off. And the things that turn on are complicated systems that could be improved. And like one of the things that's always troubled me, and if anyone else is interested in this same kind of thinking, the guy who started Visa, his name's D Hawk, and amazing systems thinker. And he's like this old man who started $1 trillion company. I don't even know how he became the CEO of Visa. I think he was like a middle manager who just had an idea. And then he like worked his way and then just started this whole thing. But after he started this $1 trillion company, he just like went to go live in the woods. But he made this comment, and I'm paraphrasing. It was something like, it was interesting to him that the systems that exist seem to do the opposite of what they're intended to do. Which it very much aligns with like a libertarian viewpoint, right? It's like you create the system of government to protect people, and then you spend your whole life in government like worried about it becoming totalitarian. It's like, there's so many different examples of this. You mentioned that I am super interested in history. I fell down a rabbit hole with that. But more recently, because of all the weather stuff that's been going on in Texas, which is where I'm based now, I've fallen into another rabbit hole of systems around houses. And I was like, why does all of our infrastructure fail? And it's like, oh, it's because people build to the absolute minimum standards of wherever they're at. So we have these standards in Texas that are like probably some of the lowest standards in the country because it never freezes. So people put their water heaters outside. And like absolutely insane things that you'd think you would, when you're young and naive, you think people consistently build to the best standards, but no, that's not the case at all. People build to the lowest standards that meet some amount, that can mean that they can recoup on some profitability.
Right.
But that you can't do that with Bitcoin. And Bitcoin is an extremely elegantly designed system. So that was what intrigued me about it. I had a core dev friend of mine, his name's Patrick. He told me that the reason why he was so interested in Bitcoin is because it combined hardware, software, and money. And he's just like massive nerd who's like, yes, this is like the perfect stack, right? So it's just interesting. And for me, the stack that brought me to Bitcoin is like, oh, this is both money and tech. This is both politics, but also the removal of politics. There's so many different ways to look at it, but yeah, it's just interesting. It's a great system, unlike most other ones.
Fair enough. So as we get into the book, right off in the book, you dedicate it to your dad, Mike Bickers, your grandfather, Mike Bickers, to your great-grandparents and all your ancestors recursively. What were you getting at there with maybe like recursively, or why was it so important to acknowledge all of your ancestors?
Oh, I love that. Yeah. So about the time that I wrote the book, my dad had passed away and my grandfather had passed away. So it was just sort of a soft spot for me. And in particular, my grandpa would talk very fondly of how how the whole Bickers family was supported by a publishing house out of London. So he talked about how he was a child at the time, but it wasn't just his immediate family. It was like the whole extended family that profited off of this publishing house. And he saw the whole thing just explode during World War II. There were these blitz bombings. He had an uncle that died in it. So when I wrote this book, thinking that they had both passed, I self-published it, but I did it in the name of that company, kind of brought it back. And it was just a sentimental thing for me more than anything else. I try and in life, I think I'm trying to figure out how to make things more meaningful.
Sure.
I don't know how many books that I'll write in my life, but obviously, now that they've passed, I'm those are the two people who I'd love to have read it. So yeah, it's just a little sentimental.
Sure. And I guess they had that Bicker and Sons publishing house in, I think, London, you were saying, and I guess that got bombed out in 1940 during the Blitz.
Yep.
So this was the first book published again under that moniker.
Yep, that's right.
Fantastic. The book is very visual, and I think you take thinking through visually, and you take these complex topics and you make them more simple and kind of easy to understand. One of the quotes you had up in front was, Bitcoin is everything people don't know about computers combined with everything they don't know about money. And so I find it really interesting that you had kind of really started to tackle these subjects at such an early age and think through them so clearly. And I'd love to get into some of them. So you kind of break down metaphors and analogies and kind of how is Bitcoin like email?
Yeah. So, my approach was like this, and this is why I lead with that example in the book is okay, I'm really interested in how Bitcoin works because I won't trust Bitcoin unless I understand that. But I was born at a time where email was relatively new and I never asked how email worked. I just used it. But from a nerd perspective, when something is new, when you're interacting with a system that's new, you don't trust it unless you understand the how, and then you can start to get to why, right? But I use email as an example because nobody knows how email works. I mean, a couple of people who work in the Silicon Valley know how it works, and nobody cares anymore because they trust it. Right. So what the example that I give is you can send an email, you can receive an email in Bitcoin, you can send Bitcoin, you can receive Bitcoin. We all know it's more complicated than that. But ultimately, we don't care when it comes to email. And in the future, we probably won't care when it comes to Bitcoin. The only difference is the consequences of not understanding that, the nuances with Bitcoin are a little bit more. There's these things you shouldn't reuse addresses, or you could send funds to the wrong address. So obviously, people have even, I would say, more fear about Bitcoin. I have an uncle who wanted me to just send him a little and then have him send it back just so he could have a dip of it, in his words, not mine. And I was okay, just because he wanted to kind of get the hands-on experience of what it felt like to send funds with Bitcoin.
Right.
We all send emails now, so it's not really an issue.
Yeah. How is public and private keys though? How does that how do you lock or unlock value with those?
Yeah, so one of the different ways that I try and approach explaining Bitcoin is, like you said, I talk about locking and unlocking. And I think it's a great way to think about it. And at a technical level, it's actually just what happens. So even though we say I sent you Bitcoin and that you've sent me Bitcoin, if we're sending Bitcoin back and forth, what's actually happening is not that we're sending per se. I mean, you could use that terminology because things are technical. You can kind of frame things in a number of different ways. But what was probably a little bit closer to technically accurate is that we're locking and unlocking funds on the blockchain. So if I have funds and I want to, quote, send them to you, what I'm actually doing is I'm unlocking my Bitcoins that I have the private keys for, and then I'm taking your public key and then locking them up for you on your behalf. Now, the reason why that terminology is a little confusing to most people is because in no place in the real world do we ever take someone's public key and lock up anything on their behalf, unless you're an academic researcher using PGP. And even then, the details are obfuscated, so you probably wouldn't understand it that way. So it can be a little confusing to use that terminology, but in conjunction with the visuals, it makes sense, right? Yeah, and an alternative way to explain this is to talk about the Byzantine general problem and to get into the cryptography of it. But I think just keeping it simple, sending and receiving Bitcoins is the same as locking and unlocking Bitcoins. Your Bitcoin never leaves the blockchain. So to send it is just, it's like that. It's more like that than it's actually that.
Right. That makes sense. And, with Bitcoin, a lot of people say like you could be your own bank. And does that
Yeah, I
make
dislike
sense
that.
too? Yeah. And why does that bother you?
I think it's a bad branding choice because like Bitcoin was started right at the time of the what do you call it? The Occupy Wall Street movement, right? So that would be a really bad time to say be your own bank because like banks suck in general. Like why would you want to be one? But I don't know. That's just my own beef. People say that because it's like you're in control of your own funds, which to some extent makes sense. But in another level, it doesn't make sense because even if you are your own bank, it's not as if you're issuing your own currency. So I don't know. Like people say that people can, but it never helped me understand Bitcoin to hear that phrase, which is why I sort of kind of disregard it. But to try and give it its due, to try and give it as much justice as I could, I would say people say be your own bank because when you're in control of your private key is you have total control of your funds and there's no third party that can revoke that control unless you've pre-authorized it with, a multi-sig or something like that.
Sure. Is blockchain like early artificial intelligence, or is it something different?
So the reason why I include that, so I talk about that in the book where I talk about, I actually heard Adam Back say it during a presentation. And I was like, that doesn't make any sense to me. And I had a negative immediate reaction to it. And then I like thought about it from the perspective of maybe a more general audience. I was like, okay, I could kind of see it, right? Like in artificial intelligence, instead of saying artificial intelligence, I would just say life. Right, like the blockchain is almost lifelike, right? Because you have this data stream that's like growing, and it's sort of beyond the control of any individual person, and that is almost lifelike. That's the limit that I could take it to. But is it like AI? It depends what people mean by AI. I think what most people mean by AI is like machine learning. Like something you're trying to create some sort of process and improve upon that process consistently. Like one of the amazing technologies right now is called GPT-3. And this technology, it's only available to researchers. It was around a while through like an app that I played with, but even now the app is paid. It's like having access to, an actual AI. It's so cool. And it's so scary because basically what you can do is you type in like a sentence or a prompt, and then you give it a length, and then it'll just complete it. And it sounds exactly like a human. So one of these core devs I know, he was saying that he was having it read all the IRC logs and trying to train the GPT-3 to respond as if it was him. And guaranteed it would fool people. And then you combine that with some of the AI photos that are now being generated, and you could just have like a whole swarm of internet astroturf bots that are talking faster than a single person could type. So there's a lot of cool stuff that's happening. Is the blockchain like that? I don't know, but it's definitely a cool, fascinating technology like AI.
Sure. And we call it a lot of blockchain, but how is it maybe more like a time chain?
Yeah. So this is because I wanted to write a book that talked about the different mental models that helped me understand Bitcoin. I thought I would lead with the idea of a time chain to just reframe the way everyone thinks about Bitcoin. I think obviously the term blockchain is a more popular term, but it was never in the Bitcoin white paper written by Satoshi, right? So what was in the original Bitcoin source code, which by the way was a lot easier to read than the current source code. So if you're trying to learn how to code to understand Bitcoin, you should Google that, the original Bitcoin source code. It's like one file, I think. I lost my train of thought. We were talking about how is it like a time chain? Yeah. So I try and explain decentralization because that's the most important part of Bitcoin. So if Bitcoin is decentralized and everyone knows that's important, but they don't quite know why. And the reason why decentralization is important is because that's what makes it censorship resistant. And if you want to understand how that's possible, right? Because we can understand the why part. We know we want censorship resistance because we don't want someone inflating the currency, and we don't want someone manipulating or inflating the currency. So we want it to stay at 21 million. We don't want it to be inflated. And we also don't want our currency to be revoked, right? So we want it to be censorship resistant. We want payments to go through. But how does decentralization achieve that? Well, when you look at the time chain model instead of the blockchain model, what I show, and it's so much easier to do this visually, but what I show is that the reason why the blockchain is decentralized is because it's not trusting a third-party source of time. So, the Bitcoin is actually the blockchain is actually creating an internal source of time by counting blocks. Now that sounds like very abstract, but I swear when I show it visually, I think it just makes simple sense. A lot of things do this. You're a clock, right? The universe is a clock. Your heart, you could tell time by your heart. And this is how our ancient people used to use that heartbeat to actually measure the time in a day. So the time in a year. So it's not unheard of. It's just very weird for a technology to do this. Now, what all other computers do is they just check an atomic clock, right? So your computer has this sort of like shitty clock. And then what it does instead to actually get a more correct version of time is that it checks someone else's atomic clock, which is like in a centralized whatever. I don't know. I'm not an expert on clocks, and a lot of cryptographers are going to correct me on all the things I said, because I don't know why cryptographers are always obsessed with clocks, but it's true. But yeah, Bitcoin is better called a time chain than a blockchain, in my opinion, which is why I explain that in the first chapter of the book.
Sure.
And Satoshi also used that as a comment in the original Bitcoin source code.
Right. And so, yeah, and just to kind of some of the facts you put in the book, there's on average 144 blocks are added per day, 1,008 are added every week. So I was kind of wondering, like, you brought it up with the time chain. So it's like time stamping, and Bitcoin has its own clock, which to me, it kind of has its own internal oracle. But why is time stamping important and or significant? And how does that work with control loops and feedback within the system?
Yeah. So, man, I apologize for talking about this verbally. It sounds kind of out there, but really just as simple as we can make it, is what is the point of a ledger, right? The point of a ledger is to track transfer of value, right? So I'm sending money to you, you're sending money to me, or not money, but value. And what do you need for a basic ledger? You don't actually need time. What you need is order, right? Because if I'm going to send you money, we need to know that once I've sent it to you, I no longer have it. Right. So that's what the blockchain does, is it provides this decentralized yet centralized ledger, and centralized meaning that there's only one. We're all settling our transfers on this same ledger. So it's hard to understand when people say blockchain, like what the blockchain does, because you're like, well, there's a block and there's a chain, but that doesn't tell you anything about anything. If you were to call it like a time ledger, that's not catchy. But ultimately, the point of the blockchain is to be a ledger, and the point of a ledger is to put transactions in some order. And the way that the blockchain does that is with blocks. So there's this really funny problem that existed among cryptographers before Bitcoin. And it was that no one thought Bitcoin, or it wasn't Bitcoin at the time, but no one thought decentralized currency was possible, because collectively, the whole industry could not conceive of a way to actually have transactions be put in some order because of the relativity of time. So if you and I are transacting and we are neighbors, and we're using full notes here for technical people or whatever, but if we're very geographically close to each other and we make a transaction, we think that transaction happens now because we just did it. But if a transaction happened, quote unquote, at the exact same time on the other side of the world, because it would take time for that data to travel, in the internet to get to us, we would perceive that transaction as having happened later, which means we would have an ordering dispute. And then the whole concept just self-destructs, right? So what Bitcoin does is it says, well, let's not care about transaction order at that level of resolution. We don't need to put every single transaction in exact order. We'll just say all the transactions that happened recently and that paid a fee, we'll group those in a block, and we'll say everything that occurred in this block happened at the same time.
Right.
And that allowed decentralization to be possible. And that block, to make it more visual, I would say the block is the tick in the decentralized clock. It's the internal rhythm of the clock. And like, once you start to see Bitcoin like that, you can have this aha moment and say, oh, I get it. This is what cryptographers actually didn't have a breakthrough on. Like, whether you think Satoshi was one guy or a group of people, doesn't really matter, but somebody discovered this and the whole industry couldn't for quite a long time. That was the breakthrough.
Right. Yeah. And so like right there, we've kind of outlined a lot, and you've thought deeply and wrote beautifully in the book. And I do agree that the book is very visual. So I do implore people, grab the book. It is the best, I think, book out there for beginners and really, I think, even more advanced people. But I love it. We've covered, economics there. We've covered cryptography, coding, programming, sort of systems, computer languages. But, now we're dipping into like ledgers and order and what really is accounting and the evolution of accounting and what, your chapter 3, information integrity and balance and validation. And you do a deep dive, here into accounting. And, I'm learning that, before the calendar was used to track time, it was used to track payments. Through your book is where
right.
What was called a calendarium in Rome was an accounting book and ledger for recording debts and payments, and calendars started therefore as financial ledgers. And going back over 5,000 years, our evolution as a literate species came out of our desire to track ownership, trade, tax, and debt. And this, I was reading this in your book, and it really made me think deeply again about accounting. I've done accounting by trade for a long time.
Isn't that awesome? We thought deeply about accounting. Like, that's so cool. How often do you think deeply about accounting? But Bitcoin will bring that out of you.
Yeah, well, and your book, then we learn more about accounting here. So let's get into a little bit of it. So, why was single entry accounting kind of flawed? And then leading into like, what is so magical about double entry accounting?
Yeah, so going super far back into like, why do people trade value? Like, what was the thing that made currency evolve, right? We start with the single entry accounting, and all that means is like, you have a guy holding, some sort of, I don't even know what to call it. It's not even paper. It's like a cuneiform tablet, right? And he's saying like, you owe me this and I have that, right? But it was extremely messy to do things that way. It would be like, what's a good example of single entry accounting? I mean, I don't know if there is a good modern example, but the point is if you're keeping track of everything you own just by writing it down and actually having it, you could very easily mess that up. And in security, we sort of have this saying where it's like, I'm going to paraphrase or butcher it, but the general point is you don't know what someone is doing intentionally out of malice or unintentionally out of stupidity. So these ledgers, these single entry ledgers, where it was just like everyone's storing their own book and they're all just like writing on this one document of what they own and what they owe. It's very easy to mess up. Obviously, you can imagine if you're running a business like this, you can't actually grow your business because it becomes a trusted thing in the business. If you were to say like, hey, you're the accountant, I'm going to pass you this piece of paper and you just keep track of it. If he doesn't write something on the document and he just takes that thing out of inventory, there would be no way for you to know. So I think it's something in the 1500s, this guy in Italy, I'm going to butcher his name, so I won't even bother saying it, but this amazing guy who's a friar, religious scholar, but also businessman, sort of formalized double entry accounting. There's no evidence to suggest that he invented it. We think that he just formalized it. Pacioli is his last name. At least I can say that without butchering it. But what he really discovered, and he came from a super Christian background, what he really crystallized for me is that if you have a business structure, you have to balance what you have with what you owe. So when you do something like, for people who haven't like maintained business books before, and I do it for my own business, but I'm pretty bad at it. When you like make sales, like that's pretty easy to comprehend. It's like, oh, we're profiting. But when you spend money on your business, now the business owes you equity, right? So this double entry accounting system was the first way to balance books and actually have equity in a company. It was the beginning of the capitalist revolution to some extent, because it allowed businesses to grow and to be able to do things that they couldn't do before. So it's hard to explain. I hope I do a better job in the book, but really what it is like, it was a way to actually validate data. It was the first database that tracked your assets and your liabilities. It tracked, because so the reason why also assets and liabilities are a bit awkward in modern English is because this was also invented at a time that medieval Europe didn't have negative and positive, they didn't have negative numbers. So they had to like bend language, right? We would just think of like, oh, well, why don't you just subtract? But no, like we're going to call that like a credit, you know? So it's like, it's really difficult to explain these things, at least to my simple mind, because I'm just like, you know, credits and debits and all this stuff. And it's kind of tricky to explain, but ultimately the progress from single entry to double entry accounting is that we went from a ledger that you couldn't internally validate to a ledger that could be internally validated. You could prove how much money you had in your business. You could prove what you owned. So yeah, it was a huge thing for industry.
Yeah. The way I think about it is single ledger accounting, I think, is adversarial. The metaphor I use there, or the analogy is, you know, the king had the ledger and you sold him sheep and he wrote down how much he owed you, and you came back next week and he said, I only owe you for 1. And you were like, what? I sold you 12. And he's like, no, the ledger says 1. Sorry. And, you know, whereas double entry is collaborative accounting, and it allows trade and verification. And so now I'm going to quote directly from your book before we get to the next thing, but I think it's important to kind of like, you know, when we think about Bitcoin, you know, we think about all these different kind of.
Oh, I should add one if I'm not pausing you too much, but I should say, we mentioned the calendar, how that used to be a ledger. What politicians in Rome used to do before Caesar came around is they used to extend their rule. So they would say like, oh, we're going to invent a new month so that they could collect rent for a second month.
Right.
And like the corruption being tied to time, because interest was tied to time. So it's so interesting how money and time and like ethics can all be tied into one. But yeah. I'll let you do your rant. I thought that was an interesting tidbit.
No, it is. And that I wish I had that in my notes from the book, because I like that point as well. But it's interesting that we think about all the facets of Bitcoin. We think about economics, we think about politics, or freedom and sovereignty and independence, but and computer programming and engineering and all these first principles. But one we don't really cover a lot is accounting. And I think it's kind of like, because we don't think there's anything very interesting about accounting, but you outline a lot of stuff here, and I want to cover from the book. So the history of data integrity technology started with the early calendars, ledgers, and databases. And then you kind of go over some really, I think, important things about just the accounting language here. So, you know, credits don't always imply a negative, and debits don't always imply a positive. In Latin, the terms debere and credere were used to mean to trust and to owe respectively. So a debit, you know, you have your debits, which you want your debits to equal credits, but your debits are, in the book you outline, is like, you think about it as receiving and wealth, and your credits are giving and income. And a debit is a transfer into the account, and a credit is a transfer out of the account. And I'm going to jump in here with my own analogy. A lot of people think of the debit card as like you're swiping, but you know, the debit is loading up the card. You know, you got 5,000 in debits.
Right.
And now you're
accountants are like, yeah, we get it. This is simple. Right. But for us normal people who don't do accounting, it's weird.
Right. I mean, I remember learning about the debit card, and I'm like, what the fuck is everyone talking about? Like, I'm going to go debit my debit card? Like, right. Like, are we going to go spend the credits? And people are like, no, it's a debit card. I don't want your credit card. And you're like, whoa, everything's getting confusing. So, you know, accounting, and we've touched on this a little bit, but accounting does have ethics, because a business can't ignore what is owed without consequences for too long. And then just to think about debits and credits. So debits, and this is all from the book, you know, but, debits are expenses, which means you utilized it. Losses are you wasted it, and assets are you saved it. Credits, you know, you can think about as loans, you need to repay them. Credits or liabilities that you need to repay, and credits could also be equity, which is kind of paying in. And the overall equation is assets equals liability plus equity, and that's where you find the truth and the ethics in accounting. And this accounting equation is an arithmetic representation of the culture's principal value in fairness and equity. So now that we've kind of covered accounting a little bit, I'd like to turn to the Fed. and ask you, like, how does the Fed maintain the facade of double entry accounting?
Yeah, well, I mean, from a simple gold bug perspective, like they used to own gold, which was what the assets were. Right. And then, so basically the Fed used to do double entry accounting. For every business does double entry accounting. We don't call it that, right? You just say accounting.
Right.
You count, you figure out, you balance your books and you make sure everything's in order. Every company does that. Every business does that. And if you don't, it's called cooking the books. Right. But for the Fed, legally, what they have done is they've just removed the component of having to own any assets. Right. So, well, it's a longer process than that, because really it was like the Treasury owned things. And then the Fed kind of comes in as a secondary player here. But gosh, it's so much. I'm such a visual thinker. But basically, what's going on in the monetary system right now is that we have these two entities that don't play by the same rules as anyone else. Right? Like the Treasury and the Fed, they don't actually balance their books. They just print debt. And an asset for one entity is a liability for the other. And it's this tricky system, which the whole thing, if it were easy to explain, it wouldn't be magic. And it has to be hard to explain so that people don't understand it. And in the book, I describe it very simply and visually, and it all makes sense. But verbally, it's very hard to pin them down on what it is they're doing, right? And that's what makes it so nefarious, and that's what makes it work. Is like, oh well, us, we have to have assets, and we are trying to explain it in this complicated language. But at the end of the day, the Fed is just buying up the debt that the government is creating. So the government creates liabilities, the Fed buys them, issues dollars. To think that your dollars are actually debt doesn't make any sense, which is why we don't get upset. If it could easily make sense, and we would all get upset. But it's just like this horrible thing. And when I was writing the book and doing research about double entry accounting, I really realized that was the crux of what they were doing. Is they took double entry accounting and the beautiful ethics of it, right? I mean, to me, that statement, it's obviously people in economics, they get like physics envy, where they want everything to line up perfectly, right? You want your economic theories to just line up in this beautiful chart. And you want to think that if you can target 2% inflation, that, you'll make the world a safer and happier place. But that's so not reality. Like when you go back in history and you look at the type of the type of economics that happened in the 1500s and the 1600s, it was totally infused with ethics, and that was sort of separated by the time we got to Adam Smith. And now I'm just ranting, but it was people in the early days of thinking about money always tied it to ethics. Like a good example of this is people used to think of money as stored labor. Now, obviously, now I wouldn't argue that we should do that. I'm just saying that there's such a detachment from ethics and money now. And the very core of that is in how the Federal Reserve and how the Treasury don't play the game that all of us have to play. They're allowed to create money in the form of debt notes, and then the other entity just buys the debt notes. It's just absurd. It's crazy and impossible to actually explain, other than, it's just debt. Yeah. And that doesn't even make sense. It's not a good way to explain it, because when you take on a debt, you have to pay it. But this is a debt that will never be repaid, and it's not meant to be repaid. Right. For economics nerds out there, you can look into modern monetary theory. Yeah. And the theory is, as long as the illusion keeps going, then the whole system just keeps working.
Yeah. I'm going to quote you, it's a kind of IOU bonds for IOU bucks. You said, but the real spell breaking question is, if I were to borrow $20 at 0% interest, knowing that you would never ask me for the $20 back, is this really a liability? And I think that's what you're getting at. Is this really debt that is owed? These assets are illusions for both parties. And then you go on to mention that the three slogans of the Fed should be: paper is gold, fraud is trust, and debt is wealth. And, it comes across very clearly that you see through the Fed. You even ask, if only a small...
I don't see through the Fed without confusion. And that's what makes me so angry, is like whenever I talk about it, the spell demands that it just confuses everyone.
Yep. And if only a small percentage of the people can see through the scam continues. And again, your words, we're living in times where the stability of our society relies on the continuation of lies hidden in plain sight with semantics. And I think we've kind of covered that.
Right.
So we're going to move back to Bitcoin a little bit and follow along with the book. So in terms of information propagation, there used to be a time where every node in the network was a miner, a payment validator, and a wallet in one. And like, how has that evolved over time?
Yeah. So saying that again, I'll just say like when people started running Bitcoin on their local, on their work computer, it was just a software that you could run, right? It was just an open source software that you would just download and run, and then you'd earn Bitcoin. And there was no differentiation between a full node and a miner and a wallet. Like, it was just one software. Now the software has gotten much more complicated, and we could talk about like why I think it's important to understand each part of that, but you tell me it's funny to me when people are interested in Bitcoin who are new, what they always want to know is how they mine, right? Like, oh, I should mine some Bitcoins, right? It's like people have no idea what mining is. So I thought that the history could kind of help people understand what these modern terms are.
So the couple points I wanted to touch on there were just, it seems like at a political level that the evolution out of having all those things in one kind of divided the miners and the developers. And one of the things that you brought up in the book was just that, that was a point in Bitcoin's history when the developers weren't really getting paid, whereas the miners were making a lot of money mining. And I thought that was really interesting. And I'd love for you to
also, the miners are mostly in China, right? And then the developers are not.
Fair enough. Yeah.
And that's caused some tension.
Yeah, there's a lot of tension. But I'd love for you to describe like the mesh model and the layered cake model of propagation cycles.
Yeah. Okay. So let's see. Describing these things without visual. So I could kind of simplify it. And I would say, like, in this mesh model, so to speak, what I'm really trying to visualize here is like, Bitcoin is this decentralized network, and every transaction has to actually physically go to all the other nodes in the network, right? So when you send a transaction, your transaction goes to its node, right? Because your wallet is probably handling that for you, because the vast majority of people aren't sending transactions through their full nodes. But your wallet is sending your transaction to a full node, and then that full node is then reaching out to 8 of the full nodes that it knows about. And then those, it'll say like, hey, have you heard about this transaction? Yes or no? If no, I'll send it to you. And then that node then does the same thing. And then you could just imagine like your transaction just propagating to the entire network of full nodes until the whole network is in agreement that your transaction has occurred. And then the miners step in and they say, okay, it actually asks the nodes, like, what transactions do you see? And then it takes all those transactions, and if it wins the game of mining, it'll group the transactions into a block and then formalize, or basically timestamp, finalize the transaction, right? So the purpose of, we could see in this kind of, in explaining it this way, the purpose of the full node is to propagate the transaction, and the purpose of the miner is to confirm and finalize the transaction.
Right.
Now, when I like make a joke in the book, I call it like a cake model, because I was like, sometimes things get too academic and I just need to make them silly. But I was thinking, okay, so like, instead of like picturing a mesh network of decentralized nodes all over the world, like, what if you just picture like a layered model? And this is really common for explaining like networking stuff. But basically, in this idea, I think about layers of a system, right? And the first layer is you have your wallet, and then your wallet is the locking and unlocking layer. So this is the layer that's going to have your private key and then actually say like, yep, you've got the funds, let's unlock that. This is the public key you want to send to. Okay, let's lock those up. And it creates a pretty transaction. And the transaction, I have to take a step back and make sure that this is correct. The transaction, yes. So the transaction is what's the first unit that's actually sent, right? So in the network, your full node is sending out the knowledge of this transaction. So now we're in the we're going down a layer. So we started in the wallet and now we're in the full node. And the full node is going to like take this transaction and then send it to the next one, right? So this is, now we're at the propagation layer, but propagation is sort of something that also happens in full nodes. It's just a different functionality of full node. So the full node will validate your transaction, make sure it's legit, and then it'll also send the transaction to your next full node. We talked about miners already, but basically miners would be the next one to confirm it. And once your transaction is confirmed, the reason why I use this layered model, I start at the top and I'm working my way down, right? Wallet, full node, miner, is that at this point, your transaction goes in reverse and then it goes back up the chain, right? Because now once your transaction's been confirmed in a block, now the whole block has to get propagated in the network. So the block has been confirmed, your transaction has been confirmed in the block, and now your block propagates. And then your full node says like, yup, this is a valid block, unless you're not running a full node and then it's not validating blocks. But if you are running full node, then it'll validate the block, right? And then then eventually your wallet will be like, yup, you do have those funds. And we or you sent the fund. In our original example, we sent the funds. So you no longer have the funds in this example. But yeah, that's what I try and explain with those two mental models. I think it helps, right? You have the network model, the mesh propagation model that helps you understand how the network is decentralized. And then you have like what I call the cake model, because I think it's funny, but really it's just like the step or the process model. It's like step 1, step 2, step 3, and then we do the steps, but like kind of in reverse. We do it for transactions, we do it for blocks.
Yeah, that's awesome. We did touch on how you mentioned, everybody wants to know about mining. How can I mine? I'm going to do all the mining. But then you say, well, maybe kind of with mining, that might be the best thing for an individual person at this point in the system. And then they feel like, well, the miners control everything. So how are the full nodes and miners similar to like a manager-worker relationship?
Yeah, so this is like a technical term. It's actually called slave-master relationship, but I thought that was like too edgy, so I like kind of dialed it down. But basically what it is it's not exactly that, but basically it's the full nodes that are in control of validating blocks and transactions. And like, if you've been in the Bitcoin space for a while, there's things that have gotten political around this, like what's technically a transaction, what's technically a block, right? We had this block size debate. So full nodes have the rules. Another way to think about them is that they have the constitution of what this monetary system is. And if you are not in alignment to the pre-agreed upon rules of the financial system, then you are not participating in this system because we had pre-agreed upon rules. So people do have this idea that because the miners are the ones that are making money, that they're the ones that are somehow in control. So you ask this, what's the slave master, or what's the worker manager relationship? But really what it is the validators are the full nodes, the units that are actually in control of the system and defining the system, defining what a transaction is, defining what a block is, defining what a valid transaction is. Those are full nodes. And all miners are doing are confirming that. Now, why does that matter, right? Because ultimately, we started this conversation saying that like back in the day, this was all one entity, right? So it wasn't intended for these things to split, but I think really early on in Bitcoin, it's sort of, I think even Satoshi saw that this was an inevitable split. These would be two entities. It would have been nice if you could financially incentivize people to run full nodes. I believe that was the intent. But because of the progress of CPU mining to GPU mining to ASICs, there was no way to do that. So for people who don't know, ASICs are just pieces of hardware that are really specified to do one thing. And the thing that Bitcoin ASICs do is they compute the hash function that allows them to play the game of mining and get rewarded with Bitcoins. It's really cool, but what that means is now you have these things called miners, and now you're taking in all these other economic incentives. Like, where does it make the most sense in the world to run a miner? I can tell you it's not here where I live, right? It's in places where electricity is free because the government subsidizes the thing. Or like China is just a good example because they have access to so much more computer chip manufacturing that it just makes more sense to do mining there. But now you've really entwined this tech system with just reality. And the reality is it's cheaper to do mining in China, and that adds a political dimension to Bitcoin to some extent. Yeah, so I don't know if that answers your question, but the way that what I'm trying to explain with that chapter in the book is I'm trying to explain that Bitcoin is very secure, and running a full node is actually more meaningful than running a miner in a lot of ways. It's always been more profitable to just buy Bitcoin than mine. Like, mining is a really hard industry to be in.
Yeah. I think Robert Breedlove kind of summed it up with, like, the miners, the full nodes enforce the rules, and you can go fork the rules of, say, the game of chess, but no one's going to play with you. And that's what gives the nodes control. And then I try to stress to people that miners don't have control in the way that they might think, but it's just, everyone wants to mine, and they think it's very sexy. And that's where all the money is.
They have no control of what Bitcoin is. They can just decide to mine or not mine.
Right. But kind of talking a little bit about mining. So, like, how is proof of work like a puzzle or a dice game?
Yeah, so this is one of the mental models that I was trying to work through myself when I was trying to understand Bitcoin. But, people, just the term mining Bitcoin is in and of itself a mental model, right? You have this picture of a guy like in a cave picking away, trying to mine gold, right? Like, that's what that whole thing is trying to get you to see. But a lot of the ways that people talk about proof of work are not that. So, like, when people say proof of work, they'll say like, oh, well, I'm computing these hashes. I'm computing hashes, or I'm what's another way that people, I found the solution to the block, right? What does that mean, to find a solution to a block? So I try and give two different examples, and I'm sort of spacing on it. So the first example that I give is I know the second one is dice. Oh, the first one's a Rubik's Cube, because I thought that this would sort of help. But like, you could imagine that proof of work is kind of like a puzzle, or like a giant Rubik's Cube that has an adjusting level of difficulty. So like, imagine like you're playing a really simple game, which is just like, I don't know, like I'm terrible with multiplication numbers. So it's like, it's a small Rubik's Cube. It's very simple. There's maybe only like 4 little squares on each side. And then you go up a level, and now you've got like 16 on each side, right? So it's a more complex Rubik's Cube. It's still the same game, but it's more complex. So you can kind of think about mining, because people will say like, oh, the difficulties increased or decreased. You can kind of think of mining as that. It's like it's this cryptographic game that was not really cryptographic. It's a game that people are playing that can scale up arbitrarily or down arbitrarily in difficulty. But the really, that's such a terrible way to explain it. And the whole point of me saying that in the book is to show how it's sort of terrible. I think the much better way to explain it is with mining, or not with mining, sorry, with dice. Right. And the reason why I use dice, and it's much better in the book because of the visuals and all this stuff, but I can actually give you a very specific example of how in playing this dice game, I can create a scenario where we're playing a very simple game of dice. I'm playing by myself, and I set the rules of the game are I have to roll the dice. And I only have 1 dice, so I have to roll the dice, and if it hits a 1, I win, right? So we know that there are like 6 sides, and we can kind of calculate the odds of that, right? Like, I have a 1 in 6 chance, assuming perfect dice. Very simple. Now, what's cool about this is like, what if we want to add players, right? So if we add players to the game, now you and I are playing, but we both have our own dice. Well, we know that if we both have a 1/6 chance of winning, one of us is going to win faster than I was going to win by myself, from a strictly probability standpoint, right? So now the rules of the game are one of us has to win 1/6. So I'm not a statistician, but it sounds like we double our chances here. So what's cool is like about this model is like, okay, we can add players to this, but we can also change the winning parameters of a game. So we could say, instead of saying we have to roll 1, like it was like, I said we have to roll 1 to win, right? But now we can say, okay, we're each gonna have 2 dice, and we have to roll snake eyes to win, right? So now we've increased the difficulty in proportion to the increase of the number of players. And that's what mining is like. Mining is like when more people do this thing called mining, then the game changes itself to become harder. And then as people leave the game of mining, then the game again changes itself to become easier.
Right.
But it's still the same game. It's still the same game, and it's an arbitrary game. It's like literally we're just computing hashes as a measure of work, but like what the heck does that mean, right? So it helps to see the visuals. I keep doubling down on that.
Yeah, no, fair enough. What is the alchemy of mining?
So I describe the alchemy of mining as, again, it's a visual thing, but what I'm trying to convey with that term is like back in the day, right? When people talked about mining, they talked about from a very materialistic standpoint. This is not really what alchemy was, but this is what everyone in modern times thinks of it. They thought of it as turning lead into gold, right? So what the alchemy of mining is in Bitcoin, as I understand it, is it's trying to turn fiat into Bitcoin, right? Because the reason why proof of work works is because we're taking off-chain resources, be it fiat buying electricity or just electricity itself. You're trying to take something of value in the real world and provably destroy it to create scarcity in this digital world. And that's a form of alchemy to me, right? So when people say mining, what they actually mean at a technical level is they're computing hashes. That's all. That's what it is.
Mm-hmm.
And when people say like, what's another example? They're mining. I think the example I give in the book is like, gosh, I'm blanking on this. There's mining, and then there's also like doing work. Doing work is the same thing. It's just computing. It's just computing hashes. So you can phrase this a number of different ways, but at the end of the day, we're taking money or electricity and we're trying to funnel that into become digital scarcity, which is Bitcoin.
Right. Yeah, and I really see that, and the way you express it is like the true integration of the real world and the digital world, where we're taking something from the real world, which is the energy, the electricity, and converting that value that it has in the real world into the digital world as value there.
Yes.
Yeah,
and people hate the word burning. I even choke up when I say that, because it's like you're burning or just provably destroying. Like that's not a good way to phrase it. There's so
converting.
You're converting, right? Yeah, you're converting. You're converting money into Bitcoin.
Right, I agree, and so I think we've covered a lot of ground here on what is Bitcoin, how does the system work, what are a lot of the underlying pillars. I really think that you think through these frameworks just incredibly well. I think you might be Satoshi. I'm not sure. So I have some other questions for you. So, like, what do you think are like some of the potential dangers of blockchains?
Yeah, so we talked.
And when I say blockchains here, I think the only real blockchain is Bitcoin, but the blockchain technology or the cryptographic technology, what might be some of the dangers here?
Yeah, I think the biggest danger is that people just simply don't understand it, and it becomes like a word that people use to manipulate other people with. And we already see that, right? Like one of the motivations for writing the book was I would see people like I would see people be swept away by language that went something like this, right? This is 10 times faster than Bitcoin, and 10 times cheaper to run, right? Like, of course, you're going to want to use that if that were true, but you have no way of actually validating if that's true for yourself. And even me, if someone makes a claim about a cryptographic system, I can't validate that claim. So a good example about that was like the DAO. And that was like it was a smart contract that was run on Ethereum. And I remember when it happened, and I thought, I don't know anyone who's read this. And I looked at the code and I said, I don't know anyone who would read this, because it's like a massive contract. It's kind of like when you are trying to pass a law in like Congress or something, and nobody reads the law that's being passed, kind of thing. These systems are really complicated, and people do sort of assume that they're all the same. Right. So they go, oh, Bitcoin, Ethereum, Ripple, Litecoin. They just put the whole thing in the basket called cryptocurrency. But eventually that's not going to be the case, right? Like the dollar is going to become digitized. And like Facebook tried this. I think Facebook was a little too soon, but they're like, oh no, we're not a blockchain. They're going to use the hype of the blockchain, but then spin it to be everything that's not the blockchain. Like the point of the blockchain is to be decentralized and to resist censorship. And do you think that's what the Facebook blockchain would be? Right? Like, absolutely not. Right. And I think I mentioned this in the book, which is what you might be trying to get me to say, but I've talked a little bit about how this is also really terrifying to me, is that the blockchain is actually a ledger that we can't stop. Like at this point, we're now running a system that is unstoppable. Because it's decentralized, we've created a data store that is going to exist in perpetuity unless you somehow magically take down every single full node. I don't know if we understand the significance of that. I mean, obviously data on the internet lives a very long time, but servers go down. And this is like this is like a network that just won't go down. We've created a completely resilient network. Yeah, I won't even walk through the potential implications of that. But to me, that seems like maybe we should stop and think about what that actually means.
Yeah, I'll touch on it a little bit. Earlier in the book, you said something that really struck a chord with me, is that a lot of what makes building the digital world interesting is trying to replicate existing human models of human connection online. So one of the reasons I really drew a lot of the connections between your thinking around like history and historical texts and calendars and ledgers and things like this. And then kind of talking about the potential dangers of blockchains, you mentioned in the book, it's not outside the realm of possibility to imagine a world where physical property is enforced by AI and managed on a blockchain. And so you think about, one, I think, Bitcoin is this unstoppable, almost life force. And it, I wonder how much it's learning about us through all our financial transactions that we that are somewhat fungible to us, or pseudo-anonymous to us, and we use our tools to fool each other, but that thing is learning everything about us, and we're putting all our money and storing our time in it, and we can't stop it. And then you kind of, to me, it alludes to, well, what if we create another life force that is unstoppable, or at least maybe state driven and not stoppable by the community that's being run by it, and so now you have all these rules in place, and it's physically enforcing things in the real world through
right. Like the reason that I thought about that, actually, I was out to lunch with one of the devs named Mark, and he started his own coin, which was amazing. But anyway, so he said very casually, he's like, oh, in the future, land will just be governed on the blockchain by autonomous AI. And like it was kind of a joke, but it was kind of like, no, it was a joke, but it was a little too possible it just didn't hit. It was like it didn't hit, or it hit too well. I don't know, but the idea that you could what is a title, right? What does it mean to own land? It means that the state has some sort of database where they say, yep, you own the land, you have the rights to it. But if we were to do that in a decentralized fashion, and then actually have like an authoritarian kind of government end up in the mix with that, I hope this doesn't happen, because ultimately,
and robotics, throw in robotics.
Exactly. But the thing that calms me down and pulls me off this ledger here is like, not ledger, but you know what I mean? The thing that calms me down with this is that decentralization is so not what centralized governments want, right? They want everything to be centralized so that they have full control. So I'm very hopeful that China or the US or whatever the next, big global government is going to be, isn't going to want things to be decentralized, but it is a very powerful thing.
Yeah, the thing that calms me down from the ledge is that, the centralized groups will fail at sort of these projects just through their own ineptitude. But I think that, they are getting smarter too, and becoming less inept, I think, or, and they're able to just through the physical might in the real world, continue their ineptitude through force for a long period of time, maybe. And I think there could be some, I hope we manage these technologies in a smart way. We'll see where it goes.
I hope.
It's very interesting. You mentioned that, in your book that, just like fire, blockchains are a tool. I wonder if Michael Saylor also read your book. And then you mentioned how some people can make weapons out of tools. I'm kind of curious, though, a little bit about maybe you're thinking about some of these other projects in the blockchain space.
I stay very ignorant, but go ahead and hit me.
Sure. And I'm not getting into like investing or anything like that, but just sort of use cases, technology, even if it gets absorbed by Bitcoin or not, or whatever, like just, take something like IPFS with IPFS Filecoin. What do you make of something like that? And is something, I think that's about file distribution, but are these distributed projects make sense at all?
I mean, Actually, it's cool that you bring up that one because out of all the projects I've seen, and he's been working on that, the main guy on that project has been working on the project for such a long time. And I think that's one that actually makes sense um, because you're giving up storage, which has value in the same way that in Bitcoin you would give up electricity that has value. So it has a form of proof of work that lines up with real world economics. Things that I think don't make sense are like proof of stake, because it's like, okay, you're going to prove that you're going to take this digital asset that doesn't have any value and you're going to hold it to prove that it is value. Like, that's not how it works. That doesn't, I mean, maybe prove me wrong. Yeah, I don't, maybe if, I don't know how this works. Sometimes, you can be an armchair economist and you could be like, nope, I don't see how that has value, therefore it doesn't have value. And that's like not how it works. So in a way, I'm like, I don't think that'll work, but I'm humble enough to be like, let the market decide. And so what I've seen in the crypto space is the market doesn't know for a long time, but just to be sure, it pumps it. And then the long-term trend is really what matters, right?
Yeah. Do you have any thoughts on NFTs?
I just talked about NFTs to a friend of mine today. He was like, I'm going to be an NFT. And I was like, how does that make any sense? Yeah. The example he gave me is like, he's like, don't you think, and I'm just talking about my friend now, but he's like, don't you think that there's a possibility where someone could be a rapper and then say, buy my NFT as a way to invest in me? And I was like, I had to really explain to him like why this doesn't work. The biggest way that I think gets people to explain this is like, everything in crypto is just seeing what people are willing to do, right? Like, are people willing to do this? But the problem with all tokens, and NFTs are included in this, is like, how do you get the token to represent the thing? Right? It's like, you can say that it represents that, but like, how does it really represent that? And we didn't get to this when we were talking about accounting, but the cool thing about Bitcoin, which some people are calling triple entry accounting, is like, okay, like in business, you have your ledger and all this stuff. But in Bitcoin, our ledger is the value. The ledger is not just balancing value, but it's actually transacting value. The ledger has now integrated the value.
Oh, right.
Like, that's crazy cool. That's not true for tokens, right? Tokens are always just a representation of the off-chain value. And then you have to ask yourself, well, what third party is enforcing that truth?
Yep.
Does that mean that people won't pay millions of dollars for an NFT? Of course not, right? People do all kinds of things.
Yeah, I agree 100%. Do you think our children and our grandchildren are going to have to imagine a world where they have to question whether they're going to be symbiotic with AI and technology?
I think that that's a possibility. I think it's a possibility. I don't know. So like, I know how my grandmother didn't know how to run my washing machine. And when I lived with her, as she got older, she had to write down instructions on how to use the washing machine. It was like, literally, she didn't know what button. And like, it wasn't enough that the buttons were labeled. Like, she needed to go back to her set of instructions written in her language. And I'm humbled by that experience, because I think, yeah, things can move pretty quickly in 100 years. And I'm not so bullish on a lot of technologies. Like, when I was in school, I did go to school for a while before I dropped out, but I thought I was going to work in like neuroscience or something. And it turns out like I'm terrible at taking tests. And like, everyone who's in neuroscience is just I don't want to make super generalizations, but if you were around in the late 2000s, people thought biotech was going to be crazy revolutionary, and then it just sort of fell flat. But that's not true for technology, and it will not be true for AI. But when technology, I mean like Silicon Valley. That AI will be very successful. It is already very successful. It's almost terrifying already.
Yeah.
So knowing that and then adding 50 to 100 years to it is kind of like, well, it seems certainly inevitable. Whether it's our grandkids or our great grandkids, it seems inevitable. Unless there's some sort of great economic instability.
I think it's already here. I'm already externally symbiotic with my phone.
There you go. That's an approach.
I don't write down the instructions to the washing machine, because in case I need them, I could Google them. and,
Right.
and use that as an extension of my brain. My kids literally hand me my phone if it's out of my hands for too long. Here, Daddy, here's your phone. You're not going to be much without it,
But now we just need to integrate it into our body, right? That's the next step. And we're very fearful of that, but maybe it won't be a big deal.
Maybe. We'll see. I do think it's going to be a big deal. I think it can go either way, but I'm hopeful, and I think it's inevitable, however it goes. My final question for you is, what do you mean by you don't roll your own crypto?
Oh, yeah. So you don't roll your own crypto. So it's a saying that cryptographers say, and it's like all it means is you don't implement your own cryptographic protocol. And I think a better way of phrasing that, because it's kind of arrogant, right? It's like no one's smart enough to write a cryptographic protocol. But I think what it actually means is like what people should understand about cryptography is when you are suggesting a new concept in some sort of forum or academic environment, your colleagues ruthlessly attack that idea and try and poke holes into it. So some of the best implementations of cryptographic protocols are battle tested, meaning that even though a person or like a team of people implemented that, it was really like a whole community that tried to attack it. So, and Bitcoin is definitely like that, right? Because you have security researchers that are always trying to break it. You have governments that are always trying to break it. It's battle tested. If you're just trying to write your own crypto, you're trying to write a puzzle that doesn't trick you, but how do I phrase this? You're trying to write a puzzle that doesn't trick other people, but really it's just one that doesn't trick you. It's it doesn't work. It doesn't work. So that's what I mean by that. Interesting last question there.
Yeah. I definitely recommend Bitcoin Clarity, the complete beginner's guide to understanding Bitcoin. What is Bitcoin and why it's important? You'll learn what Bitcoin is and how it works without cryptography or code, what mental models are and how we can use them to understand Bitcoin easier, why Bitcoin works at all and what makes it different from other blockchains, how value is measured, created, and captured, what Bitcoin is worth, if it's worth anything at all. I've read a lot of, sort of intro or entry level books to Bitcoin. I thought this one's incredible. I think it might be my favorite one yet. I hesitate, I think it is intro. I think it's definitely a complete beginner's guide, but, I really think that, there's more to it than just understanding Bitcoin here. There's a lot of the mental frameworks you bring to the table, the way you think about systems, the way these different not industries, but, economics and, programming and cryptography and accounting integrate, I think is really fascinating. I still think you might be Satoshi. I'm not sure. I'll leave it to you for any, parting words, and definitely let people know where they can find you. I know you do your own show, your own pod, you're on YouTube, you got the book, you're on Twitter, but, definitely let people know the specifics, where to find you.
Yeah, I'm thinking about doing a podcast with Tone. I think some people maybe watch his thing. But yeah, I'm on Twitter, although I never tweet anymore. Really, I love writing, and I think that's the medium that I'm going to stick to because I think I communicate my ideas the best through there. And I see that you have like just tons of notes for the book. I'm super flattered by that. I love it when people can take something actually constructive and if it can help people on their journey down the rabbit hole. It's like you said, it's not just for beginners. It's for people who have been in this space for a long time and want to see Bitcoin from the perspective of a cryptographer without actually being one.
Yeah.
I hope that's the perspective that I'm bringing to the table. That was my aim in writing the book. I want to write another book called Crypto Chaos. So it'll be a sequel to that one. So we'll have Bitcoin Clarity and we'll have Crypto Chaos. And I hope to document like the history of cryptocurrencies, all the things that have been tried and have failed, and how things are sort of being revived and tried again. I think that'll be good, but God only knows when I'll be done with that. But yeah, definitely follow me on Twitter, follow me on YouTube. I make some videos on there sometimes. But thank you for having me on your podcast.
Yeah, that's super interesting. Because this book, you speak a lot about how we learn order from chaos. And, and I think, Bitcoin has really brought a lot of order to my life. And so I'm very excited for your next book. I love the way you think, and this has been so incredible. Thank you for coming on the pod. Thank you so much.
Thank you for reading the book. I appreciate you. You have a good one.
You too. Be well. Kiara Bickers, systems thinker and author of Bitcoin Clarity on mental models, information propagation, and understanding the Bitcoin time chain, right here on the Bitcoin Matrix podcast. And thank you for listening. If you dug the chat, please subscribe, rate, and share with your friends and family. That's the best way to spread the good word. This is Cedric. Peace.